Hello and welcome to your 14th Algebra 2 class, and today we are talking about multiplying matrices. Now, multiplying matrices is slightly different than adding matrices, and the reason is because the rules are somewhat different. Now, I am going to give you a couple of examples, so I'm actually going to give you one example, talk a little bit about the rules, and then we're going to go on to another example, right? So you might see that this video could be divided into maybe 1, 2, or even 3 parts, depending. All right, so let's get to it. Now, matrices. We've talked about matrices. We know that matrices are made of rows and they are made of columns. Now, I actually found this exercise on another YouTube tutorial. Very good. I'm actually going to see if I can upload it along with this video lesson. And we need to understand what are rows and what are columns. Now, in a matrices, or matrix, rows are horizontal and columns are vertical. So if we look at matrix A, we have one row, but we have 1, 2, 3 columns. And if we look at matrix B, we have 1, 2, 3 rows and 2 columns, okay? Now, in order for us to be able to multiply a matrix A times B, the number of columns in the first matrix must be equal to the number of rows in the second matrix. In other words, the 3 here has to be equal to the 3 here. The number of columns of the first one has to be equal to the number of rows. Okay? Since they are both 3, that means I can multiply this matrix. Now, our resulting matrix is actually going to be a matrix that has 1 row and 2 columns. So we're going to get what is called a 1 by 2 matrix, because this is a 1 by 3 matrix, 1 row, 3 columns, and this is a 3 by 2, which is 3 rows, 2 columns, and our answer is a 1 by 2. Again, the number of columns, which in this case is 3 columns because they're vertical, 1, 2, 3, must be equal to the number of rows of matrix B, which is 1, 2, and 3. So I know I can multiply them. If the number of columns of the first one is not the same as the number of rows in the second matrix, you cannot multiply them. Now, let's look at the matrix, okay, and let's multiply them. So we're actually going to multiply all of these numbers right here by the first column, okay, and then we're going to add them. So this is what I mean. You're going to multiply 3 times 4 plus 1 times 2 plus 4 times 6. Okay? And 3 times 4 is 12. 1 times 2 is 2. And 4 times 6 is 24. So that's actually 12 plus 2 plus 24. And 12 plus 2 is 14, and 14 plus 24 is 38. So that means that our first row is going to be 38. Now we're going to do the same thing with the second column. So we're going to multiply this first row by the second column. And we're going to multiply 3 times 3 plus 3 times 5 plus, 3 times 3 plus 1 times 5 plus 4 times 8. Let me write that there. 1 times 5, 4 times 8. So 3 times 3 is 9. 1 times 5 is 5. 4 times 8 is 32. And 9 plus 5 is 14. And 14 plus 32 is actually 46, which is also our second. It is a much smaller matrix. What goes in our second column? So we have 1 row and 2 columns. Okay? Very simple. Again, all I did was I multiplied the numbers of this row, of the first row here, by the numbers of the first column. So again, 3 times 4 plus 1 times 2 plus 4 times 6. So 3 times 4 is 12. 1 times 2 is 2. 4 times 6 is 24. And I add that and I get 38. And then I do the same thing, but with the second column. So 3 times 3 is 9. 1 times 5 is 5. 4 times 8 is 32. 9 plus 5 is 14. 14 plus 32 is 46, which means that my answer is a matrix of 1 by 2. 1 row, 2 columns. Now, I'm going to be back with another example, so go ahead and pause this video and rewind it and practice that problem over and over, and I'll see you in a few seconds. Probably already saw the first example, you probably reviewed it, you probably went over it again and again. Now let's look at this one. Now what if we wanted to do the opposite? What if we wanted to multiply matrix B by matrix A? So we're still using the first matrix that I gave you guys, right? And we have matrix B. Now matrix B, remember our rows are horizontal, our columns are vertical, has 3 rows and 2 columns, and matrix A has 1 row and 3 columns. Now it's very important to note that in order for 2 matrices to be able to multiply by each other, the number of columns in the first matrix must be equal to the number of rows in the second matrix. So the number of columns here is 2, but the number of rows in A is 1. Since the columns and the rows are not the same, I cannot multiply B times A. Now you need to be very aware of that, very mindful of that, because sometimes A times B does not give me the same result as B times A, okay? So I'm going to go ahead and erase that, and we're going to look at another matrix. So I'm actually going to go ahead and erase all of this so I have some space, all right? So very important that we take into account. Now what if you have the following matrix? What if we have matrix A, which is 3, 4, 7, 2, 5, 9, and that is a 3 by 2, so 3 rows, 2 columns, and matrix B is 3, 1, 5, 6, 9, 7, being 2 rows and 3 columns. So the first thing we want to see is if in fact I am able to multiply them. Now the rule states that the number of columns in the first matrix must be equal to the number of rows in the second matrix. So the number of columns here is 2, and the number of rows in this one is also 2. So that means, one, that I can multiply them, and secondly, that the result is going to be a 3 by 3 matrix, okay? So how do I multiply them? Well, the pattern is very simple. You're going to multiply rows by columns. So you're going to multiply the first row by all 3 columns, the second row by all 3 columns, and the third row by all 3 columns. So this is what I mean. So the first row is going to be 3 by all, and you're going to multiply it by the columns. So 3 times 3 plus 4 times 6. First row, first column. 3 times 3 is 9. 4 times 6 is 24. And 24 plus 9 is 33. So that's actually, I'm actually going to write it over here for now. And I know that my first number is going to be 33. But I have to multiply it by the second and the third columns respectively. So now I'm going to say 3 times 1 plus 4 times 9. And 3 times 1 is 3, and 4 times 9 is 36. So 36 plus 3 is 39. So my second number in my other matrix is 39. Now you're going to multiply the first row by the last column. So we're going to say 3 times 5. Now notice the pattern is row times columns. Row times columns. 3 times 5 plus 4 times 7. So 3 times 5 is 15. 4 times 7 is 28. And 28 plus 15 is 43. So if you notice, I have my first row. Now let's go on. So the pattern continues to be the same. Rows by columns. So that means I'm going to multiply this row by all 3 columns. So I'm going to say 7 times 3 plus 2 times 6. Remember, rows, columns. And 7 times 3 is 21. and 2 times 6 is 18, and 21 plus 18 is 39, so that would be the next number here. Then I'm going to multiply 7 times 1, again, rows times columns. 7 times 1, 7 times 1, and plus 2 times 9. Plus 2 times 9. So 7 times 1 is 7, 2 times 9 is 18. 7 plus 18 is 25. And again, 7 rows and columns. 7 times 5 plus 2. So 7 times 5 plus 2 times 7. 7 times 5 is 35, 2 times 7 is 14, and 35 plus 14 is 49. So now, again, rows times columns, so it's going to be the third row multiplied by the third column. So that's going to be 5 times 5 plus 9 times 7. 5 times 5 is 25, 9 times 7 is 63, and 63 and 20 is 83, and 5 is 88, so that equals 88, which is the number I'm going to get down here. And then you're going to multiply, actually, the 88, I did it backwards. The 88 is actually the last number, because I started again. So now we're going to multiply row times column. So 5 times 1, which is 5, and 9 times 9, which is 81, right? 9 times 9, which is 81, and 5 plus 81 is 86, and then we're going to multiply 5 times 3 plus 9 times 6, and 5 times 3 is 15, and 9 times 6 is 54, and 54 and 10 is 64, plus 5 is 69. And that's how you multiply. Remember, always rows times columns. So first row by all 3 columns, second row by all 3 columns, and third row by all 3 columns. Now remember, you multiply first row by all 3 columns and you add. Okay, second row by all 3 columns and you also add. Third row by all 3 columns and you add. So guys, this is it. Feel free to pause and rewind this video. I'm going to upload your practice problems along with a supplementary video that will help you guys out. So stay safe and I'll see you soon.